In this video, we are going to wrap up surface area with surface area of composite solids. So our essential question is, how do you find the surface area of a composite solid? So finding the surface area of a composite solid, we're going to kind of think back to when we found the area of composite figures, our two-dimensional shapes. We basically broke it down to our basic two-dimensional shapes or polygons and then found the areas and then added them all together. Now this is going to be very similar with a solid, but it does get a little more complex because we are dealing with a three-dimensional shape. So the thing we need to do, the most important thing we need to do is step one, identify the shapes on the surface of the solid. So we're going to kind of work our way around this three-dimensional shape and identify the shapes or the polygons that are on the surface of the solid. Then we can compute the area of each face, knowing and using the formulas we've learned, and then add them all together. But be careful to only find the area of the exposed faces. Now we're only talking about the area on the surface. That's why it's called surface area. So we're only talking about the parts of our composite figures that are on the actual surface of the figure. So here is an example of a composite solid. Now this is not one of the basic solids that we've learned about, but it is made up of a couple of three-dimensional shapes that we are familiar with. Now there's a lot of ways to divide this shape up into basic solids, but I'm just going to pick one and I'm going to roll with it, so just bear with me. If we imagine kind of cutting this right here, so I've got now a prism on top and a prism on the bottom. So I've got kind of two separate prisms here. Now, if you can imagine those, try to make these clear here. So I've got these two prisms kind of stacked on top of each other. Now my job is to list all of the polygons that make up the faces on this solid and then find their areas. So I'm just going to start with this kind of front face right here. So the front is actually composed of kind of this rectangle right here and then this rectangle here. So if I find the areas of those, I can find the area of the front of this composite solid. So the front, this is 16 by 8. This is also 8. And this is 16 total. This is 8, so that means this is 8 as well. So these are all 8 right here. So this bottom square is an 8 by 8 square and a 16 by 8 rectangle. So I've got a 16 by 8 rectangle plus an 8 by 8 square. Now that's just this front face right here. This is what I'm finding the area of right here, this front. I'm going to call that the front. Okay, so 16 by 8. 16 times 8 is 128, and 8 times 8 is 64. So that's 192 square inches. Now the nice thing is the back, now if you'll imagine the back side of this on the other side is going to be identical. So the back of this solid is also 192 square inches. So now I've got two sides of this solid computed. Now we need to start looking at the other sides. Let me clear this off so it doesn't get too jumbled up here. So now we've got the front and the back taken care of. Now we need to start looking at the other sides to this composite figure. I'm going to go ahead and do the top. The top is this rectangle right here. I'm trying to find this area on the top, and that's a 16 by 6, since this measurement is 6 right here. This is a 16 by 6, so the top is 16 by 6, and that is 96 square inches. So the top is 96 square inches. Now I need to find another side, and I'm just going to kind of work my way around. I'm going to do the left side over here. So that's kind of this side over here. You can't see it because it's hidden. So if you can imagine this back side here, that back rectangle over there, we're going to call that the left side. So that is, what is that? 6. Because these are all 6 here, 6, 6, that's 6. This is 16 by 6 as well. So the left side is 16 by 6, which is 96 square inches. So now I've got those faces taken care of. So I've got the front, I've got the back, I've got the top, I've got the left, and I'm just going to kind of work my way around. It's nice to kind of stay organized and keep your pattern the same here. I'm going to do the bottom. So the bottom is right here. We can imagine that. And the bottom here is going to be an 8 by 6 rectangle. And that's 48 square inches. And then I'm going to do the right side, which actually the right side is kind of composed of 3 rectangles over here because it kind of juts in and out. So let me clear that off. So I'm going to do this right here. This is 6 by 8 as well. So this is going to be considered part of the right side. So that's 6 by 8, which is 48 square inches. And then there's this guy right here that's kind of underneath. And that's also 6 by 8, which is 48 square inches. And then finally, I've got this right side right here, which is another 6 by 8. So there were 3 6 by 8 squares, or rectangles, sorry, on the right-hand side. So that's 48. And then I've worked my way back around to the top again. So I've got front, back, 1, 2, 3, 4, 5, 6, 7, 8 sides. And that's what I have. So I know I've got all my sides. And that's the hardest part of surface area, is making sure you've got all of your sides. Now I just need to talk to my good buddy Adam. I need to add them up. So I add all these areas together, and my total surface area is 768 square inches. See, notice how I did that in a nice organized way. There is no way in the world you're going to do this surface area in your head. So you have to write down all of the sides of this object or this solid in order to get this correct. Okay, there's just no way you're going to do this mentally. It does require a lot of writing. So surface area of composite figures is probably going to require the most writing we've done in any of these calculations. So let's look at one more. Here we have a pyramid on top of a cube. Now this one's going to go a little bit faster because we have a lot of faces that are duplicates of each other or that are the same. So I'm going to start with this top pyramid. Now, when I talk about only the exposed faces, not every face of this pyramid is exposed. Like the base of this pyramid touches the top of the prism below it. So those faces are not on the surface. So I'm not going to include those in my surface area calculation. The only parts I'm going to include on the pyramid are the actual triangle parts to it. So that's what I'm going to find. I'm going to find the triangles. And they're all identical because this is a cube. So all of these triangles are going to be the same size. They're all going to have a base of 8. And then remember, this is my slant height right here. This 5 feet is the height, the actual height of the pyramid, which we actually don't need at all. So that's too much information there. So I'm going to use this slant height and the base, which is 8. So the triangles are 1/2 base times height, which is 1/2 of 8 times 6.4, which is 25.6 square feet. Now, there are 4 of these triangles on the top of this figure, so I'm just going to multiply that by 4 since I know they're all identical. So that's going to be a shortcut way to get through those because I know they're all the same size. So all my top triangles are 102.4 square feet. Now I just need to do the bottom, this cube, which is nice because these are all squares. Every face on this cube is a square, and it's an 8 by 8 square. So the squares are going to be 8 times 8, or 64 square feet each. And there are 1, 2, 3 in the back, 4 over there, and then 5 on the bottom. There are 5 of those squares, so I'm going to take that times 5. 64 times 5 is 320 square feet. So these are all the top triangles, all the bottom squares. And then I need to talk to my buddy Adam, and we add them up to give me a total surface area of 422.4 square feet. So the one we did first, we had to do each face individually. And then this one was a little bit shorter because we had identical faces, which we could shorten up by multiplying. So finding the surface area of composite solids, you have to list the faces and you have to write them down and find them individually and then add them up.